안녕하십니까? 저희를 환영해 주셔서 감사합니다. 이렇게 아름다운 도시에서 여러분과 함께하는 시간을 가지게 되어 정말 기쁘군요. 제 이름 Patricia Hines-고요. 미국 뉴멕시코 주에서 왔습니다. 뉴멕시코 주는 Home of Spaceport America, 라눈 이름으로 잘 알려져 있는데요. 저는 쿨 뉴멕시코에서 나사가 주관하는 스페이스 그랜트 프로그램하고 또 앱스코어 프로그램의 디렉터를 맡고 있습니다. IAC organizers, distinguished guests, and colleagues, hello on behalf of my colleagues and myself. We thank you for this marvelous welcome that you have provided for us over the last 2 days. You have a beautiful country and a beautiful city, and we look forward to spending this next hour with you. The title of the plenary session is Civilian Access to Space for Mankind. What's in it for the engineering, commercial, and scientific communities is what we hope to discuss today. For the purpose of this plenary session is to examine the global implications of civilian access to space for profit. I invited these speakers because each has begun to address the problems of increasing access to space for civilians and how this increased access has potential to greatly benefit the scientific and engineering communities in the near future. This panel will be a discussion panel. If you have questions, please write them and give them to the people who will pass them on to me. We will leave some time before the end of the session to address some of these questions from the audience. All of the panelists have agreed to stay after the session is over. For those of you who want to continue to discuss with them your questions. I will now introduce the panelists. I will start with each panelist, will introduce themselves and talk about their company, and then we will end that initial introduction period and begin the question and discussion period. I will be introducing Will Whitehorn first, president of Virgin Galactic, the world's first spaceflight space lines company offering suborbital space flights to the paying public. Mr. Whitehorn is in the company of his collaborator, Mark Sarangelo, who developed the engines for his vehicle. And we have George Neal with the FAA, who is the regulator of this industry. All of us are working together to help grow this industry. I introduce Will.
Thank you, everybody. Welcome to Dijon. We have a very short video to show you, which we will start with before I say a few words and before I hand on to my colleagues. Could we show that video now? I hope we have a video to show. Yes, we do.
This will be a trip like no other, and will give those that travel with us a unique and life-changing perspective of our planet. For most of us, escaping the constraints of gravity is something we've only been able to achieve in our dreams, until now. Virgin Galactic is now on the final stretch to becoming the world's first commercial space line. Our suborbital space trips promise to be the most intense and wonderful experiences that our passengers have ever had. we, and I hope you, will be travelling on a spaceship owned and operated by Virgin Galactic. Our spacecraft have been designed so that each of our passengers will have the room and the freedom to enjoy the amazing sensation of weightlessness. Large panoramic windows will allow you to see clearly the curved Earth over 100 kilometers below and the colours of the fragile atmosphere protecting our vulnerable planet. We had spent many years on a frankly fairly futile search for technology that could be developed into a vehicle which would meet our specifications for safety, environmental impact and commercial viability, and of course the potential for a great customer experience. But Rutan Spaceship One and those flawless history-making X-Prize flights in 2004 suddenly changed all that, and we grabbed the opportunity. I remember chatting to Brian Binney, the pilot on the X-Prize flight. He said it was a journey of contrast, describing the enormous forces that pinned him to his seat and the tremendous noise as the spaceship powered out of the atmosphere. Then suddenly, the dramatic and absolute silence of space.
The vibrations go away, the shrieking, shrilling noise of that rock motor disappears, and you get this instant karma of weightlessness. You cannot appreciate the experience just by looking at a magazine cover, just what it is like to take it in with your own eyes. And everything you feel in your body is the same way. It's wow.
Since the announcement in 2004, the project has reached and passed many important milestones. We have a truly inspiring design for our home at Spaceport America in New Mexico, an ever-increasing family of pioneering customers, and of course, beautiful new vehicles, now in an extensive test program before they start commercial service. I hope you will be as excited and inspired by Virgin Galactic's mission as I am, and see you up there.
Well, ladies and gentlemen, what you just saw on that film is the world's first commercial space line, and we think the first commercial human-carrying space launch system which will exist. And what I want to say in the very few minutes I've got, and I think my colleagues will follow a very similar theme, is to talk a little bit about why this particular type of space flight is so important. One of the things about space, which since the history of the Apollo program in the 1960s has been misunderstood, has been why space has not moved forward very quickly into an era of human spaceflight going not only into orbit around the planet but beyond the planet. If we look back to the late 1960s, Sir Stanley Kubrick in the film 2001 predicted an era within 40 years whereby the Pan Am spaceplane would be traveling to the moon carrying passengers. It didn't happen for the simple reason of economics, not because of the science or technological ability of mankind. Because space launch after the 1960s became very much that of a mission-by-mission project. A mission-by-mission involving the space shuttle, the Soyuz, the Ariane rockets, and the economics of space remained very elusive to the idea of ordinary individuals being able to go into space. And that really, to the project that we're working on, the Virgin Galactic project, is the absolute key to our decision to develop the system you just saw in the film. We've developed a system which we believe will be able to carry people into space for less than $200,000 a head for the experience of their lives. But that will provide us with the regularity of flight to allow us to develop a mass-produced rocket motor solution with a fully reusable vehicle system. Those economics from carrying people twice a day into space from Spaceport America will consequently also allow us to approach other marketplaces. The marketplace for commercial satellite launch, for example. We've designed that White Knight 2 aircraft stroke space launch system that you just saw to be capable of also launching an unmanned rocket, capable of launching a 200-kilogram satellite for less than, we hope, about $2 to $2.5 million a launch. And with a capacity with the White Knight to do up to 4 launches a day of an unmanned rocket into space, which would allow you to launch constellations of small satellites and cube satellites as well. But in addition to that, because of the requirements and the market research we did about the space tourist customers, of which we've got 300 now, We also got into a situation whereby we realized we had to build a big enough spaceship to allow it to do space science as well. So our system will be capable of carrying humans in the loop to do space science and microgravity experiments in the suborbital flight up to 140 kilometers above the Earth that we'll be able to undertake. And that's a very exciting prospect. So for me, the journey to mankind being able to get into space is also going to be a journey to allowing us to use this vehicle for space launch and space science in an affordable way for a much greater audience of people out there in the industrial world and the scientific and university world have ever had access to before. Anyway, I'm going to pass on to my other colleague now. Thank you very much.
Thank you, Will. If I may introduce now Mark Sarangelo, Executive Vice President and Chairman of Sierra Nevada Corporation Space Systems. As I mentioned, he built the engines for Spaceship Two, but of course they have their own company, a world-class prime system integrator and electronic systems provider known for its rapid, innovative, and agile technology solutions. Thank you for joining us, Mark.
Thank you. I'd like to just start by giving a few comments on who we are as a company. Sierra Nevada is a 2,000-person company that is involved with a variety of aerospace activities. In the space arena specifically, we operate through 30 offices as a company throughout the United States. And we have focused on really three main topics. The first being we're one of the larger builders of small satellites. And the second being that we're a significant builder of subsystems and components for many primes and many space systems. And thirdly, we're involved with creating propulsion systems, specialized propulsion systems like we're doing with Will and Virgin Galactic. Through those combination of those three activities, we've added a fourth recently, which is the development of a global, an orbital space vehicle that we call the Dream Chaser. The interesting thing, I think, as we speak here in the commercial world, one of the fascinating parts of this is that, as we've heard Richard Branson say on the videos, that there's an inspiration. Recently, I got to go to the 40th anniversary of the Apollo moon landings in Washington, and as the podium came up, we realized that hanging up behind us was the original Spaceship One motor in the Smithsonian, as well as Spaceship One itself. And you begin to realize that as you get to be parts of this kind of industry, that there are moments of inspiration that come up. The other thing I think is very interesting about the commercial world as we're talking about it today is that we exist as collaborators, we exist as vendors, as clients to each other. The lines are very much blurred. Our business might at one point develop motors for Virgin Galactic and scaled, and at the other side as a satellite operator and manufacturer we might be using them to launch things. And I think as we look at the world today, we're realizing that there's a significant change in the way that people can do business in this regard. We also realize that things are a lot closer than many people may anticipate in terms of where this industry may be and the points that it may get to. And it's very critical that not only do we have industry collaboration and partnerships, but we also have partnerships with the government. And we've had a terrific relationship with George and the FAA, and they've been doing some really wonderful work in not only monitoring what's going on in the industry, but approaching it in a very realistic fashion. And as we roll this out globally, we hope that that model will be something that will be used throughout the world in terms of government-industry relationships. So I'm very happy to be here with my colleagues and my friends. Pat.
Thank you, Mark. I would next like to introduce Dr. George Neal, the Associate Administrator for the United States Federal Aviation Administration, the Space Transportation Division, whose mission is to ensure protection of the public property and the national security and foreign policy interests of the United States during commercial launch or reentry activities, and to encourage, facilitate, and promote the U.S. commercial space transportation business. So, George.
Thanks, Pat. I don't know how many of you realize it, but tomorrow is the anniversary of a very important milestone in aerospace history. October 14th, 1947 was the date that Chuck Yeager first broke the sound barrier in the X-1 rocket-powered aircraft. As we reflect upon that historic achievement, I think it's very appropriate to look at the progress that has been made in the industry and to speak a little bit about what the future may look like. This is a very exciting time for commercial space transportation. And part of the reason for that is that there are some very dramatic and far-reaching changes that are coming in terms of how we conduct space operations. Up to this point, government agencies have really dominated our human spaceflight efforts. However, over the next few years, I expect that private industry is going to play a very key role in both low Earth orbit operations and suborbital spaceflight activities. Let's talk about how things may play out. First, after 28 years and well more than 100 flights, NASA is in the process of retiring the space shuttle. And once they have completed the final flight, which is currently scheduled for late next year, NASA has committed to rely on private industry to take food, clothes, and other cargo to the astronauts on board the International Space Station. Last December, NASA issued $3.5 billion worth of contracts for SpaceX and the Orbital Sciences Corporation to pay for the first several years of this operation. And because these flights will be commercial launches, they will require a launch license from our office at the FAA. A second big change has to do with the fact that we are really on the threshold of what I'd like to think of as a new era in space transportation, and that's commercial human spaceflight, or specifically, suborbital space tourism. Our office is working right now with about a half a dozen companies, each of which is in the process of designing, building, and starting to test vehicles that can take people up to the edge of space so that they can look out the window and see the black sky and the curvature of the Earth and experience the magic of weightlessness personally. Now, we know not all of those companies is going to be successful. Some will encounter unexpected technical difficulties. Others will have financial problems, whether it's raising the funds to do the development or making their business plan close. But there are enough very capable groups out there that are highly motivated and have spent significant amounts of money to date, such that I am very confident that within the next 5 years, we're going to see multiple companies, each able to conduct several flights per week on suborbital missions. And that means that we'll be seeing hundreds of launches every year, allowing thousands of people to personally experience spaceflight. That's really going to change how we think about space. I think for the first time, we will have opened space up to people all over the world. And that'll be a very exciting day.
Thank you, George. I'd like to pose the first question to Will, and then we'll interact. George painted a picture in the next 5 years of what you hope to see, and what we all hope to see. Will, would you paint the picture for what it is you feel Virgin Galactic will be able to accomplish in the next 2 years? 5 years is a long time.
In the next 2 years, with the system that we've developed, we will be in space, I think is the easiest way to put the answer to that question. We've been conducting, as you could see on the video that you saw at the start, with our own system. Our own system is air-launched, and our launch vehicle is unique. Nothing has quite like it ever been developed in aviation. It's the world's first 100% carbon composite, very large, high-altitude aviation vehicle. It can lift 17 tons to over 50,000 feet, and it can launch a variety of different vehicles from under it into space. The spaceship that you saw in the video is Spaceship 2. That will be unveiled to the world on December the 7th this year. It will then go into its ground period of flight testing. It will then be captive carried. It will then do glide testing at high altitude. It will then fire its rocket motor for the first time. It will then go supersonic. It will then go into space. And it will then be part of a process to get a launch license from the IAC to begin flying commercially. It will launch its commercial flights at Spaceport America in New Mexico. And as I said in the brief introduction, the important thing about this project, and one of the reasons that Virgin Galactic is so excited about it, is that we have developed a vehicle with a multi-role capability in space. A vehicle that is fully reusable from the point of view of both the human-carrying spaceship and obviously the launch aviation vehicle. The spaceship is also entirely carbon composite. It has a unique feathering device that you saw in the video to bring it back to the Earth. And we will have, in the first year of operation, I'm not going to give you a date for the first year of operation yet, because I think that's between the FAAST and its licensing process and ourselves, and we're only in a race with safety. Therefore, we don't commit to an actual date when we'll start flying commercially. But over the next 2 years, we hope to move to commerciality. And we already have these first 300 customers. In 2 years' time, we expect to have the first 700 customers. In the first year of operation, we expect to carry more people into space physically than have been there since 1961. But we also expect, within a very short time from the beginning of operations, to start doing space science missions with the science community, who can, for the first time, do human suborbital space science with the humans in the loop in that space science, rather than having to use a sounding rocket. And I'm confident that we will also be in the small sat business within a year of that. Our colleague Dr. Adam Baker, who's in the audience here today, has just joined us from Surrey Satellites in England and has embarked, as of the last week, on our small satellite development program. And that will be a program whereby we look at designing and building our own launcher, or having that done for us by the other companies in the private sector. And we would hope to begin that process within the next 6 to 7 months of actually issuing the RFPs for that launch. So we have a very, very busy 2 years ahead of us, and I'm sure those 2 years will have culminated in space launch.
Thank you, Will. Thank you, Will. I have some questions here, but I am going to ask Mark, because it is important that we understand what it is Mark's doing. Some of the things are similar to what you're doing in terms of the landing profile for both vehicles, but Mark's vehicle is an orbital vehicle. So Mark, would you give us some background on Dream Chaser, if you would, and then get into a little bit of the in terms of mass, the type of mass we can lift, and any specifics you can give us on the three options in terms of humans in cargo or all cargo for your vehicle as well, and a time frame. So we're going to come back to cargo a little bit more, Will, because there's some interest, as we were hoping, from the scientific community on using these vehicles for not only suborbital microgravity research, but orbital and certainly atmospheric characterization, etc. So we'll get back to, and we'll address that. But if you would, Mark.
Sure, thank you. I think I'll start with talking about how there is, I think, a very good synergies between what we're trying to accomplish. Our vehicle is an orbital vehicle. It's intended to take people and cargo to orbit, but also is intended to do, as Will, I think, very eloquently discussed, multi-missions. And it's a real critical part of this commercial space industry, is that most everything that we do, we look at all as an industry in more than one way. It's not one mission per one vehicle. Our vehicle is intended to take people to orbit, to also bring cargo to the space station and other destinations in orbit, but also to do things like satellite servicing and satellite deployment. And as a satellite maker, Sierra Nevada is one of the largest small satellite makers in the world right now. We have a need to figure out not only how do we launch the satellites to orbit, but how do we then take care of them and service them. We currently have backlogs of several dozen satellites that are due to launch in the next few years, and several more dozen right after that. And it's becoming a very interesting time for us to be able to look at not only the logistics of building, but the logistics of launching and servicing. This past week, we've just opened up our first manufacturing facility for satellites in an environment where we're building satellites more on an assembly line basis than on a one-off basis. That will allow us to get to economies of scale and will allow us to really hopefully jumpstart an industry and a market that will eventually lead for the need for what Will was talking about, suborbital research and suborbital drops of satellites, as well as orbital drops of satellites. Our vehicle is somewhat unique in that what it does is it takes off vertically and lands horizontally. The horizontal landing can be done on virtually any large runway. It needs about 3,000 meters to land. It lands at very low G-forces. We think somewhere between 1.5 and 2 Gs. And as a result of that, there's a market that is also being serviced. There's considerable amount of research being done on the space station. The space station is being seen as a laboratory in reality now, not just in theory. And when work gets done in space, it needs to be returned back to Earth. And currently, the abilities to return things to Earth are fairly limited, and certainly to return them in a manner that maintains the integrity of the experiment and the science is very limited. So as we're targeting where we're going with our structure, we're trying to attempt to look at not just the ability to bring people to space, but to look at 3 or 4, perhaps even 5 critical missions that can be done in LEO and can be done on a commercial basis. And a lot of people look at the commercial world and they ask, what does that really mean? Virtually every business that I know that's involved with space is out there intending to make money these days, and while we all work with governments, we're all commercial enterprises. I think for our purposes, what this means that makes it a little bit different is the way that we operate under contractual bases. Most of certainly our company and others that are in this business, like Will was saying, we're looking at space as something that we're going after in a per flight, per person, per pound mode, so that the way that we're contracting, the way we're delivering is quite different than perhaps it has been done in the past. And I think the other thing that is very important to all of us is the ability to do things in a large volume method. None of these systems are made to be one-off. They're meant to do either weekly flights or perhaps even someday daily flights. And to be able to look at that economy of scale and change the dynamic of the economics behind the industry. We are seeing, certainly in the satellite world, where we're able to, by virtue of building dozens of satellites on a consistent platform, drop the cost by 50 and sometimes even 100% to what they had been just a few years ago. And if those costs can come down, and if we can gain access to space in a much more effective manner than has been done in the past, then all new industries will be opening up. Much like when the internet finally went to global broadband, we saw industries that were created that no one even knew a few years before the internet hit that type of plateau. And I think we're going to see the same thing in space as we move on.
Thank you, Mark. As you can see, these are not short answers because they're complex issues that we have to address. And that is, this space tourism will be a catalyst for our industry, certainly. Space tourism is a very interesting part of this business. But will you talk a bit about what your plans are for using your system for investigations in microgravity and suborbital environments initially? And then we might as well address orbital, might as well talk about that while you're addressing this issue for the longer term as well.
I think there are a couple of points that are worth making. First of all, in order to use a space launch system to carry a human being up who wants to see the planet Earth and wants to experience going to space, you need to work out what that human being wants. And it became very clear to us in 2004 that any human beings who wanted to pay to go to space a couple of $100,000, one of the things that they demanded in return for committing and giving us a deposit for a ticket was they wanted to experience weightlessness, and they wanted to be able to move around in the cabin of the vehicle. They didn't want to be in a very constricted environment because they wanted to take home that souvenir to show their grandchildren of them doing what they've seen being done in the movies. Now that was a great starting point to be able to develop Spaceship Two as a vehicle capable of suborbital space science as well. So we designed a number of features into Spaceship Two quite deliberately. One, a very large cabin that you saw in the video. Secondly, and most importantly, we also designed Spaceship Two so that there were no moving parts when it was in space. You could not only give the space tourist customer the experience of the silence of space, as Brian Binney described it in the movie, which you cannot experience on the space shuttle, you cannot experience in the ISS, but of course space is silent. And to be able to experience the silence of space, you don't want any moving parts. And that means that Spaceship Two for microgravity research during its parabolic curve is a very, very, very good vehicle for doing both instrument proving in space. So taking up instrumentation you may want to take into orbital space, might want to use it on an orbital vehicle in the future. A very good way to test it would be able to take it on a suborbital vehicle with a human in the loop. And another very good thing to be able to do is to be able to take racks of experiments up there that aren't going to be interfered with in any way by electronics or too much internal radiation within the cabin of any sort from other instrumentation. And Spaceship Two is an ideal environment for that as well, according to the space scientists who we've talked to about it and consulted with. People have consulted with us from all over the industry. People like Dr. Alan Stern, the former head of science at NASA, certainly helped us with some of the thoughts about the interior of Spaceship Two. But one other thing that exists in America to allow us to think about a vehicle for both human space tourism and the economics of that helping us to do human space science with that vehicle are the fact we have a regulatory environment in America which is unique in the world. The Commercial Space Launch Amendment Act of 2004, with responsibility obviously for FAA-AST to have for human commercial spaceflight, has created a regulatory structure which we can now manage as part of our process of going for launch license over the next couple of years for commercial launches. And that would be true for commercial launches carrying space scientists and space tourists. So I think the things that we have got going for us at the moment are, one, what the space tourists wanted, created an ideal environment for space science in the vehicle for doing microgravity work, and the regulatory environment in the United States was ideal for the development of the system. Something we couldn't have found anywhere else in the world at the moment, where there isn't really the kind of legislative base to do this in the private sector. It would have to be done as a government project. And the other important thing about Virgin Galactic that many people in this audience will kind of not think about in front of mind is the fact that we are not funding this project at the moment with any government subsidy. This is all being done on the basis of markets that are being developed. Our second round investor has come into the project because we've already got $40 million in deposits from potential space tourists, and because we can show these markets exist for small low Earth orbit satellites, the markets for suborbital space science. So all of that coming together in that regulatory environment has really allowed us to develop what we're developing.
Thank you, Will. Well, as long as we're talking about the regulatory environment, George, there's something very important about the transparency of the FAA-AST work. You know what the critical path is that you have to do. You will have, with the FAA, you have collaborators and you have enablers. Will you talk a little bit more to that role in terms of the transparency and the ability to get licensed, and what you feel that will, in taking that leadership role, what do you feel it might do for the global space industry, and particularly the industry we're talking about right now?
Well, thanks, Pat. That's a great question. If you think about what's at the heart of that, it's what is the role of government in this whole industry? And that's a very important question, and one in which all spacefaring nations are going to have to come to a conclusion on that subject in the next few years. Now, in the United States, as Will mentioned, the Congress has passed legislation that gave our office a twofold mission. First, ensuring public safety, but then also to encourage, facilitate, and promote the industry. And that's a very important combination. Certainly, safety is our top priority, but if safety were the only thing that we were concerned about, it would make our job a lot easier, because all we'd have to do is say no. And that's not really the answer we're looking for. Spaceflight is inherently risky, and the concern would be if we're trying to guarantee safety, we might make it so difficult that folks would not be able to fly at all. So we want to do all we can to mitigate the risk, to make the vehicles as safe as possible, but at the same time, we want to have the transparency, we want to be open, we want to understand all the risks that are involved. We also want the government to act in a good government type of way to encourage, facilitate, and promote this industry, and to do what we can to knock down some of the bureaucratic obstacles that may exist by working with our partners at NASA and State Department, Commerce Department, and other government agencies to do what we can to ensure a safe and successful industry going forward.
Thank you, George. Mark, this is kind of an open-ended question. In your experience, you've been in the business a long time. You've been operating in a number of different areas within space transportation industry. In terms of the regulatory environment that you work within, have you experienced this regulatory environment as something that you have found that is actually probably a good way to enable you to clearly figure out your pathways so that you have some ability to predict the steps that you have to go through to achieve your next set of goals in collaboration with government regulatory environments as enablers, not as restrictors?
I think this is it's a terrifically interesting time that we're in, and one of the things that sometimes gets forgotten is as commercial companies, as entrepreneurs, as businesses developing these kinds of activities, we look at the industry and we're seen as innovators, but at the same time that we're innovating, government has to innovate as well. And what we're finding is that we're pretty much entering into uncharted territory. And for us as commercial enterprises to look forward and try to determine what to do in the future, you're quite right. There needs to be some knowledge and understanding of what we're getting into, and that's a very difficult thing to do. That's why it's so important to have legislators who not only understand the issue but are aware of the fact that it is a growing, developing issue. No different than when we test our rocket motors or our space planes, we do so incrementally, and I think the government regulation has to come along and not suffocate the industry as it begins, but be more of a partner within what we're doing. And I think that's what George and his team are doing right now, that there is a real partnership and an understanding of the industry, and that has to develop alongside of the entrepreneurial side of the commercial industry.
Thank you, Mark. There's some great expertise in our audience, and some of the questions that we're getting are very varied. We're going to switch gears here because there is something that also impacts our ability to persist, sustain and succeed, and that is the economy. I remember being with you last year in Scotland as you were we were looking at the stock market, and it was quite a ride that one was too. We have had some economic anomalies in the last year, and all of us have experienced them in one way or another. I would like to pose this question from the audience to both of you folks. The overall commercial spaceflight industry, the ones we're involved in, has actually had, recently reported by the Tory Group, a 6% growth. So in terms of this being a growth industry, let's talk about what the impact was on both of your companies.
Right, that's an interesting question. I think if we remember the reason why the economic events happened of the last 18 months, they're complex, but they were to do with a number of things going on all at once. Obviously, there was the credit crunch that came about as a result of the loosening of credit after September the 11th, and the way that the banks then lent that credit. But there was also a crunch to do with some fundamentals going on in the provision of goods and services around the planet. We had an oil price spike in 2007 that sent oil to $147 a barrel. That was a contributing factor. And we had definitely the beginnings of real resource shortages as the economy grew very quickly after 2004-05. The world could not produce enough resources to cope, and that led to inflation in the price of commodities at the same time as a loosening of credit. And at the same time, of course, is a period where, in absolute terms, the world's population is growing now at one of the greatest rates that we've seen, not in terms of percentage growth, but in terms of actual numbers of people being added now every year. So we've got population growth, we've got resource dislocation, and we've got loosening of credit, which have combined together to create the current situation we're in. Now, from the point of view of the space industry, none of that is necessarily going to prevent the growth of the space industry as a whole, because there is a much greater perceived need around the world by all sorts of institutions, both private and public and scientific, to have more knowledge of Earth observation. So the satellite industry, I would say, has been having quite a good time of it throughout this difficult economic period. And I think that also, obviously, a lot of space science is geared to the future and the solution of problems in the future. And it's quite clear that, you know, there are very interesting things capable of being done in space now which aren't done at the moment, such as solar power from space, for example, such as taking the heat out of our IT industry and putting much more of our server capacity into space and communications capacity into space. So none of those have been particularly bad from the point of view of the space industry as things to allow it to continue a growth pattern. But interesting enough, in our little corner of the bit that's helping to fund our contribution to that, space tourism, we've noticed very, very little impact from this on the people who can and want to go to space. When the credit crunch happened, we lost a number of customers. One of our customers was a victim of Bernie Madoff and the Madoff scandal. And in fact, the only thing this particular individual had left was the $200,000 they'd left with Virgin Galactic as their deposit. So they had to ask for that back as they unraveled the situation that they were in financially. And we lost a few customers. But what has amazed us is that the difficulties in the economy have not stopped the growth in the sales of the tickets for Virgin Galactic. And we are just now going over the 300 barrier and just going above the $40 million, despite that very difficult period in the economy at the end of last year. So I think I am optimistic for private space. I'm optimistic that it will find the customers. And I'm optimistic that this industry as a whole is, partly as a result of the kind of things we're doing and SpaceX are doing and Mark's doing with Sierra Nevada, and partly because of the regulatory environment that George is managing, I think we're in for an industrial revolution in space over the next decade.
We also agree with that. I think that from our perspective, it's been quite interesting. We've seen out of difficult times, and there's no doubt there have been difficult economic times, sometimes in those periods of difficulty, there is an interesting dynamic that happens, which is that there's a willingness to look at new alternatives and a willingness to change. We were fortunate in that we were not relying on outside capital. We're self-funding as an organization, so we were able to weather that and actually have gotten much more aggressive. It's a pretty good time for us. We've been able to hire. We're in a hiring mode, so there are many more people who are interested in working. We're also seeing that there is a lot more receptiveness to the idea of using more cost-effective ways of doing business in space, such as small satellite constellations provide, and have seen our backlog grow as a result of the economic downturn. Now, no doubt there's also been some delays in government funding and the way that the government looks at the future. But overall, it's been a very optimistic time for us, and we've actually been looking forward to the next couple of years as a result of the industry changing and the way it has been as other companies have gone through some difficulties. It's actually consolidated in some way the industry, and it's made it more open to new change, and we're one of those companies that I think is going to take advantage of that. And we feel very strongly that that working in this industry right now is a really good place to be.
One other quick comment. Over this next decade, we are going to see governments around the world looking for more cost-effective solutions, because one of the comebacks of the current economic situation is that state spending will be constrained in most of the major economies of the world, particularly countries like the United States, the European Union, Japan, And even in China itself, there will be some constraints on public expenditure. Therefore, lower cost solutions for the things that still need to be done will be looked for. And that will actually aid a further industrialization in space.
Well, that one went well. So, I have a question, and we're going to switch gears just slightly here. I wanted to start with George, but actually, let me ask you guys too. We're talking about a global industry now and collaborators. For example, right here in Korea, we have the Nari spaceport just become operational. And we have Kari, of course, and we have an astronaut that's recently flown from Korea. And we also have a small satellites, microsatellite research program here in Korea. This sounds like a silly question, but I'm sure that we expect there will be some customers in the audience. Would you, all three, let's talk about collaborations, international collaborations. And George, why don't you start? I know you don't have a vehicle, but still international collaboration is very successful. It's a path to success for us.
That's a great question. We have tried to put more of our attention on the whole international outreach area recently. And one of the reasons for that is that there is so much interest in space all over the world. Now, not every nation can afford to have its own space program in the traditional sense, but what we're seeing, especially in some of these suborbital space tourism proposals, the idea is that one could have a number of locations all around the world where you could have a spaceport that these vehicles could operate from. And that will allow the local communities, the states, the countries to start to reap some of those benefits of space in terms of high technology, the economy, inspiration for the students in school, and other benefits. And the nice thing about this type of growth is it's also going to be building an infrastructure that when the technology advances sufficiently on the vehicle side, we'll be able to shift from just an up and down space tourism type of operation to a point-to-point transportation system through space once we have a network of spaceports around the world. And that, I think, is something that many of us can appreciate here. If it could enable us to fly to the other side of the world in 45 minutes or so instead of 14 hours, that would be something I'd be very interested in. Now, in terms of cooperation with other nations, certainly there are limits on how we can share space technologies from country to country, but what we have found is there are many countries that are very interested in our regulatory regime, and so we have had discussions with a number of nations in terms of how have we set up the system in the United States in terms of granting licenses, in terms of allowing these operations to be conducted in a safe manner. And we try to be very open in terms of all of our material being available on our website, and we're happy to meet with other groups in other countries about how we have chosen to set up our structure with the hope that other nations could come up with a system that is compatible and thereby help the entire industry around the world to grow together.
I would also just quickly add that I think in terms of international cooperation, the one thing that a system such as the one we're developing at Virgin Galactic is crying out for, and the thing that we don't have the resources to develop at the moment, is a new type of engine. I think the space industry generally, if it looks at itself into its heart, I think the development of an air and non-air breathing single engine would be one of the great breakthroughs in the industrialization of space. And I think as an area for international cooperation, it has to be the one at the top of the list.
We've seen our international relationships and partnerships triple in the last 2 years. We had 4 ongoing relationships 2 years ago, and we're now up to 12. And we see that as a growing trend, a positive trend. Now, certainly there are limitations and regulatory issues, but as a basis, we're building the business to look at it as being a global enterprise and are welcoming of new relationships to the extent that we can do them legally.
Thank you all. One last question here. The panel yesterday, the plenary agency discussion evolved a lot around environmentally sound approaches and taking advantage of space-based Earth observation platforms to enable us to go to the next step in terms of investigations of global climate change. So we can investigate large systems, ocean systems, desert systems, forest systems, etc. But for us, here, now, within your business models, say Virgin's and with Sierra Nevada, in terms of cost effectiveness, what are you doing within your businesses to actually look at your practices and what you are going to learn from your own investigations of how to sustain your businesses using environmentally sound practices, everything from fuels to the way you're going to be operating your companies. So we might as well talk about that for a moment, since it's...
I'm very conscious people have to go as well, so be very quick. From the point of view of Virgin Galactic, everything we're doing is about a low environmental impact because, when it comes to transportation businesses, generally speaking, the truism is that the lower the environmental impact, the lower the cost of the operation as well. And obviously, in using carbon composites, we're using a very interesting material for the future of transportation, one which we need to learn about, and we can learn about very well in this space environment, as opposed to having to do it in a commercial aviation environment. We've basically designed the White Knight 2 to be a vehicle very capable of running on biobutanol as well as running on Jet A1 aviation fuel. The rocket motor is pretty benign. It's based on a rubber and laughing gas rocket motor that was developed for Spaceship One, a hybrid motor. And we're very confident that this will be an extremely low environmental impact business, especially it's going to be operating at Spaceport America, which Lord Foster and Foster & Associates have done the design work on with the state of New Mexico, and is going to be the world's first carbon neutral transportation hub. And I think that gives it an exciting prospect as well.
Just to quickly add, the rocket motor that we are using is based on a recycled rubber core base, which is environmentally friendly. It's actually getting such a designation here in the United States. And we're continuing to look at how we expand that to other operations we're doing.
I want to thank all of the panelists for being here, taking the time and effort to be here, and to address the questions. There were many questions from the audience. We got to a number of them. And for the audience, thank you for participating, everybody.